All right, I'll do a short video that will go through a construction of an equilateral triangle and also a little extra talking about an isosceles triangle. Remember, an equilateral triangle has all equal sides. This also eventually leads to all angles being equal, and because triangles add up to 180 degrees, if they're split up equally, each angle will be 60. But that's a lot of extra information, so let me get back to the construction. So if I'm given a length this long and they say create an equilateral triangle with this length, I can place the point of my compass down here to use that to kind of measure the length of the line segment. All right, and know that every side has to be this long. All right, I'm going to do this the long way and just say if I stretch this radius line of the compass means that the other side has to be this long. It's going to be somewhere up here. If we were just using a ruler, we'd float it around until we found it. But if we're using a compass, I know it's going to go along this line somewhere. If I keep this the same length going from the other direction, saying, okay, this is this long, all right, they meet right here. So that gives us the magic intersection point that says it is the same distance from here to here as this. And again, going back from the other side, going up, it's the same distance here, the same distance here, the same distance here. So I can use that intersection point to know that is the equal length, creating this equilateral triangle. So this side, basically the radius is the same there, there, and there. The side of the triangles are the same. These angles would also be the same, all 60 degrees, as I mentioned, with equilateral triangles. So it's a pretty handy construction and pretty simple to do. Now, I did want to go on and do an isosceles triangle as well. All right, because really all of our other constructions, believe it or not, if you look carefully, are going to be variations of these constructions as the equilateral triangle and isosceles. But anyway, so let's say I want to do an isosceles triangle with a base of this, and I want the two sides to be this long. It's really very similar to the isosceles. The only difference is in an isosceles triangle, two sides are equal. Equal, congruent, whatever word you feel like using. So I'm going to measure the length of this side with my compass and say I need the sides to be this long. I'm going to place a point on what I'm going to call the base of my isosceles triangle and say, okay, well, that side has to be that long. It's going to float somewhere in here. I don't know exactly where until I float from the other side. The other side's going to be just as long. The magic intersection point where this side will be the same length as this side is right here. And if I connect those, I get an isosceles triangle where this side is the same as this side, and that means this angle would be the same as that angle. All right, and eventually you might notice if we carried this through the relationship between this one, if we followed it all the way down to the other side, all right, I should have did a longer picture, but this leads us into our perpendicular bisector construction as well. But that's all for now. Equilateral triangle and an isosceles triangle.